Okay guys, today we're doing 6.5, differentiating between U sub and boost and divide. So basically what I'm going to be doing is I'm going to be throwing in on today's worksheet a bunch of U sub and boost and divide problems, and you're going to find the integral of them all. And you're going to basically have to be able to tell whether or not it's a U sub or a boost and divide. Okay, so I'm mixing all the integrals up. Okay, so let's just go through how to do that. Okay, when do you use U sub? Okay, so remember I told you use U sub whenever you see chain rule. Okay, I'm sorry, I thought I had the answer on here. Whenever you see chain rule. Okay, so whenever you see the chain rule for a derivative, that's when you're going to be using U substitution. Okay, and you're going to use boost and divide whenever you can write it out in terms and you can boost every single term without messing around with one of the other terms. Okay, so let's just show you one here. Okay, so this one, is this chain rule anywhere? And your answer is no, there's no chain rule here at all. What you have is you have basically like quotient rule, right? And you can split this up to have it in terms. Remember, you can rewrite this as 3x to the fourth over square root of x minus 6 square root of x over square root of x plus 7 over square root of x dx. Okay, now it's in terms. Now, if I wanted to take the integral of these terms, I'm going to have to write it so it's only, there isn't a numerator and denominator, but just a numerator. So let's put these together. So remember, all these are the same as 3x to the fourth over x to the half minus 6x to the half over x to the half and plus 7 over x to the half dx. Okay, so that's what the square roots are, basically just a half, right? Okay, now if you have division with the exponents, then we need to subtract, right? Now this is the same as 4 over 1, and so what we're doing is 4 over 1 minus 1 over 2, which means we need to have a common denominator, which is the same as 8 over 2, right, minus a half, which is the same as 7 over 2. So this one right here would be the integral, and I haven't taken an integral, so I'm still putting the integral sign, 3x to the 7 over 2 minus, well, x to the half minus x to the half cancels, so it's just the 6. And this one, we're not subtracting, it's just moving to the top. So plus 7x to the negative half power dx. Okay, now since I have them in terms, with the one variable being raised to an exponent, I can boost and divide each one of them. So 3x to the, remember we're adding 1, or 2 over 2 in this case, so it's going to be 9 over 2 divided by 9 over 2. And remember that division by 2 works its way to the top, okay? Minus 6x plus 7, we're adding 1, so it's like adding 2 over 2, yeah? And that's going to make it x to the half divided by a half, which is 1, and then remember the 2 moves its way to the top. And then since we took the integral, don't forget your plus c. Okay, this is the same as, well, the 9 cancel out to make a 3 on bottom, so we're going to have 2x to the 9 over 2 over 3, yeah, minus 6x plus 14x to the half plus c. And these division by 2's, remember that's square roots. Easier to write them as square roots. So square root of x to the 9th power over 3 minus 6x plus 14 square root of x plus c. And there is my integral of that problem. Okay, let's go on to the next one. Okay guys, so let's look at this next one here. If you notice this one, it is chain rule. If you look at the top here, you have a function within a function. That's telling you that it's going to be U sub because you have chain rule. Okay. Now that doesn't mean that I'm just gonna work through it. Okay. You can still make it a boost and divide problem by multiplying this out 4 times in this case, but there's no point. I would just do U sub. So the first 3 steps, find U, find du, find dx, okay? U is going to be the stuff on the inside. So in this case, x to the half plus 3. I rewrote that square root of x as x to the half. Okay, now take the derivative of this. Well, that's going to be a half x to the negative half. The derivative of 3 is nothing, dx. Okay, and that can be rewritten as 1 over 2 square root of x dx, with that square root of x being on the bottom because it had a negative exponent, right? So it needs to move to the bottom. That whole thing needs to move to the bottom, so it's not like that. Then you solve for dx. So in order to solve for dx in this case, you are going to be multiplying this bottom portion to the other side where the du is. So it's going to be 2 square root of x du. Okay, now I have u, du, and dx. The next step is substitution. So we're going to have the integral of u to the fourth over square root of x. And then instead of dx, I'm putting 2 square root of x du. Now, if you notice here, the x's should cancel out. Square root of x cancels out with square root of x, leaving me with the integral of 2u to the fourth du. Okay. Now I can boost and divide. So 2u to the fifth power over 5. And that's the integral, so now I write plus c. Okay, this is going to be 2. Instead of u, the last step is switching u for the x values. So it's going to be square root of x plus 3, all raised to the fifth power, all over 5, plus c. Okay, and that is the integral of that one, and that is u substitution. So notice I knew it was u sub because I saw chain rule, okay? And I believe that's all of them. Good luck on the worksheet.